Yeah, they, everyone told me you were absent, but they hadn't seen you.
No, just Anthony.
Well, Anthony's everyone, apparently, in this case. It's fine. So the plan, then, for today, we're going to continue this idea that we had started on Monday. So on Monday, you worked on using the unit circle to evaluate like sine of pi over 4. And the second delta math on Monday was like going back and saying, okay, sine of what angle is square root 2 over 2. So we're going to talk a little bit more about that idea of going backwards. So far, so good. So that's the plan for today, is talking some more about that idea of going backwards. Now, I'll talk for, about half the class, like 45 minutes or so, and then you'll have the other half to work on some stuffs. So let's start there. So I'm going to start this with kind of like just a little bit of a discussion about what we mean by this going backwards process. So what we're looking at here is the graph of sine. All right, this should look familiar like we've done in the previous chapter. If I graph like y equals sine x, this is what we get. Now, if I'm trying to figure out what values of sine give me 1/2, so 1/2 is like maybe right here. If I track over, there's an answer here, and then an answer here, and then an answer here, and an answer here, and an answer here, and here, and what do you notice that's happening here? How many answers am I going to be getting? Infinitely many. Okay, well that's not great, because if I try to take this function then and create an inverse for it, you guys talked about inverses last year in your Algebra 2 class. So like if I try reflecting that graph across the line y equals x, I get the one here in kind of boldface. What do you notice about this graph? What's the problem with it? The boldface here, one on the bottom, yep.
It goes up and down on the left.
Okay, why is that a problem though?
It's like the same.
Ah, that's it, Emily, yeah. That this is not the graph of a function because it fails the vertical line test, right? So if I try to create a going backwards function, the way we had created inverses before, that's not going to work the way we want it to, because that's not a function. I can't program that, because for any input, I have actually infinitely many outputs, and yuck. So what we typically do when we have a situation like this where I'm like, okay, I have a function, and when I try to make its inverse, the inverse is not a function. What I do is I go back to the original, and I'm going to restrict its domain. So I'm just going to look at one little piece of my function for sine x. Basically, I'm going to restrict it from this minimum to that maximum.
Sorry, I swallowed my water up.
It's okay. So if I do that, if I restrict the domain from that minimum to maximum, what I'm left with is just that piece in boldface. What do you notice about this guy that's different than the previous one?
Looks like a tangent.
Well, I mean, kind of, but it doesn't have an asymptote on it.
No.
But what it does do is it passes a vertical line test, which is what we want. So this function here is going to be our function for sine inverse. So the catch is that the domain and range now are a little bit funny, but that's kind of unavoidable if we wanted a function. So your inputs for sine inverse have to be between -1 and +1. And the outputs that we'll get are only going to be between -π/2 and +π/2. If we follow a similar process for cosine and tangent, we'll get the following results. And this is essentially what's programmed into your calculator when we do sine inverse, cosine inverse, or tangent inverse. Now, let's do a little reminder here. So I've written these intervals for the domains and ranges, right? These are interval notations. What's the difference between a bracket and a parenthesis when I write an interval notation like that? Do they mean the same thing? No, they mean two different things. Does anybody remember what the difference is between like a bracket, like we have here, versus a parenthesis, like I have there?
Isn't a bracket like only for real numbers?
Nope, not quite. They're both for real numbers. Emily, you have a guess? Perfect. Yeah. So what Emily's saying is that essentially -π/2 belongs to this set because of the bracket, but -π/2 would not belong to that set because of the parenthesis. Or if you want to think about this as an inequality, the brackets are or equal to inequalities, and the parentheses are strict less thans or greater than inequalities. So that set of domains and ranges is going to be really important to us. Because if I ask you guys to do a problem like the following, we're going to need to remember those. So this next example says find the exact value of sine inverse of -1/2 without using a calculator. So if we have a problem where we ask for an exact value, it involves a sine, cosine, or tangent, we know we're going to be needing to use the unit circle. So if you don't have your copy of the unit circle still on your person, I have a stack of extras on top of the file cabinet. You're welcome to come grab one at any point if you realize that, oh no, I don't think I have that anymore. But we're going to be, as soon as you see exact value, and we're in trigonometry class, almost certainly we're talking about using the unit circle, particularly, absolutely, if it has like a sine, cosine, or tangent in it. So I'm going to go and steal myself a copy of the unit circle and just kind of drop that in there for us. So I remember on the unit circle, sine is y. So I'm looking for the places where sine is equal to -1/2. So I'm going to go along and look at my unit circle points. Come on, you stupid thing. My goodness. All right. So if I look at the y coordinates, I'm looking for things where I see a negative 1/2. So I see one there. And continue looking at my y coordinates. I see another there. Everybody so far so good? So my answer is 7 pi over 6 or 11 pi over 6. Too bad that those are both incorrect. The reason they're incorrect is because I know, since we're talking about sine, the range of outputs for sine inverse has to be between negative pi over 2 and positive pi over 2. So if I look at, if we leave the pi's off, sometimes it's a little easier to think about. So we're looking at between negative 1/2 and positive 1/2. If I look at 7 over 6, is that in between negative 1/2 and positive 1/2? No, right? Is it too big or too small? That's too big, right? 7/6 is bigger than 1/2. And I would do the same thing with 11/6, right? Is that in between negative 1/2 and positive 1/2? No, it's also too big. So neither of these answers land inside of that acceptable range of values. So what I'm going to do is I'm just going to find an answer that's coterminal to each of these. So to find an angle that's coterminal, I'm going to be adding or subtracting 2 pi. Since these angles were both too big, we are going to be subtracting 2 pi. Is everybody okay with that plan? So to subtract 2 pi from 7 pi over 6, what do I need to have in order to do this subtraction? I have to have a common denominator, I think is what Max is saying. So I think about 2 pi as 2 pi over 1. What would the common denominator be between 7 pi over 6 and 2 pi over 1? 6. So I'll multiply the top and bottom by 6. So I have 7 pi over 6 minus 12 pi over 6. Pretty good. How do I subtract two fractions when they have a common denominator like that? Does anybody remember back to like 6th grade when you would have been learning this? That was a long time ago. You just subtract the numerators, right? What is 7 minus 12? So I have negative 5 pi, and the denominator always stays the same when we're adding and subtracting. So let's check now. Is negative 5/6 in between negative 1/2 and positive 1/2? No, that's too small. So this one is not going to work at all. Let's try 11/6 then. So I'm just going to write 2 pi as 12 pi over 6. Is everybody okay with that? Just cut to the chase with the common denominator there. Now, my question is negative 1/6, is that between negative 1/2 and positive 1/2? yes, right? Negative 0.5, positive 0.5. 1/6 is like 0.16. So negative 1/6 is definitely in there. So this is our answer. Is everybody okay with that? Bless you. So again, we're just looking our values up off the unit circle. But if our values from the unit circle don't land in the desired range, we're just going to have to either add or subtract 2 pi until we get an answer that does fall in that range. How many answers will I get? Only one. Should only be getting one. Tommy.
So if you, like the first part, we figured out that it wasn't right, does that automatically mean the other one is?
Well, it means the other one's going to give us the right answer, but it doesn't mean 11 pi over 6 is correct. Right? We still have to subtract the 2 pi to get the new answer. But we should always check that other one too in case we made like an arithmetic mistake. Because if we get both of them not working, we know we've made some kind of mistake somewhere. Right? So it's a good thing to go back and check to make sure. Does that feel okay?
Yeah.
So this is basically the same process as yesterday, or as last class, when you're doing the second part of that delta math, where we're going backwards and just looking the number or the angles up off the unit circle. Except we've added this extra step now, where there's only like a certain range of values you're going to be looking for. So we convert our unit circle answers into the correct answer, the answer we're desiring, if it doesn't already fall in there, by adding and subtracting 2 pi till we find one of them that does. Cool? Okay. So that's still basically the same process as last time. What I want to talk about next for today is something like this one. So this says evaluate sine inverse of negative 0.32 using a calculator. Now, even if this didn't say using a calculator, you should recognize that this is not going to be a unit circle problem, because if I look at negative 0.32, that sure as heck isn't a unit circle coordinate, right? Is everybody cool with that? That the only unit circle coordinates are like 0, a half, root 2 over 2, root 3 over 2, 1, or some combination of division of those things. Everybody's okay with that? All right. So, well, what I'm going to do, if this is all that I'm given, is I'm going to open up my calculator. I'm going to press second and the sine button to get sine inverse, and then type in negative 3.2 and just press enter. If you have your calculator with you, I invite you to do this at the same time and make sure that you're getting that 0.326 number that I just got. If you get 18 something or another, that's the other likely result. Oops, that should be a 6. Did anybody get 18 something or another from this? Abby, you did? What do you think the issue is if you're getting 18 instead of this 0.3, negative? Yes, it's the mode of your calculator. So if you got 18 point something, you need to change your calculator from degree mode to radian mode. Naya. Yeah, there's one in the power strip right over here. Why don't you plug yours in and grab one of these to borrow, and then you can trade out at the end of class, and you should have a nicely charged calculator for homesies. Sure thing, dude. Cameron. Sure. Does everybody feel okay there? Okay. If you're able to successfully use your calculator, that's half the battle. And I need this from... Now, what if we change this problem setup just a little bit? So we're asked now to solve for theta if sine theta equals negative 0.32. And our answer for theta needs to be between pi over 2 and 3 pi over 2. We're going to do a couple of examples like this to give you guys a feel for what's going on. So to start this problem, I'm going to start by drawing a picture. So I'm going to draw my xy axis, and I'm going to think about my answer for theta. My answer for theta needs to be between pi over 2 and 3 pi over 2, so it needs to be a positive number, right? So what I'm going to do is I'm going to try to figure out what quadrants on my unit circle, or on my xy axis, are covered between pi over 2 and 3 pi over 2. So since we're doing a positive angle, I'm going to count counterclockwise, and 90 degrees is the same thing as pi over 2. So if I count, I have that. Is everybody okay with what I've drawn there? So my two quadrants that are covered between pi over 2 and 3 pi over 2 are quadrants 2 and 3. Is everybody okay with how I did that? The next thing I'm going to do is try to narrow that down to just one of those two. So the way that I'm going to do that is I'm going to say, okay, well, I also know that sine theta is negative. So if I do all silly turtles crawl, I know that sine is negative in quadrants, 3 and 4. Is everybody okay there? So what quadrant does my answer have to lie in? Quadrant 3, right? Where they overlapped, where we are between pi over 2 and 3 pi over 2, and where sine is negative. So I'm going to draw the terminal side of my angle somewhere in quadrant 3. So that's my answer, is what it looks like visually. Is everybody okay there? Okay. Certainly. So far, so good? Okay. What I'm going to do now is define part of my answer. So the part of my answer that lies between the x-axis and the terminal side of my solution, so that right there, I'm going to call that angle alpha. And in our case, alpha is going to equal sine inverse of the absolute value of negative 0.32. Why is it sine inverse? Because it was a sine problem. Why is it negative 0.32? Well, because that was what the sine was equal to. Will it always be absolute value? Yes. So far, so good. All right. The last thing I want to do is now write my equation to find my angle theta. So to do that, I'm going to be using the picture. This is why I've drawn the picture, so that I can do this step right now. So if I start at 0, I've gone past a half a pi. We go to a full pi. So theta is going to be a pi plus some extra, right? How much extra? Alpha extra. So I'm going to go to my calculator and do pi plus sine inverse. And if I want to put the absolute value in, I can do math, go over to NUM, short for number, and pick ABS, short for absolute value, negative 0.32, and then press enter. So my answer should be 3.47. Now, do I really need my calculator to do the absolute value of a number? That's something we can do in our head, right? So when I'm going to do it from now on, I'm not going to type the absolute value into my calculator. I'm just going to do that part in my head and cut out like all those extra buttons and menus to step through. But I'll write it down on my paper that I did the absolute value. I just won't do it on my calculator. Deal? I just want to be clear so that nobody's like wondering what happened to the absolute value. We're just going to do it in our head. But we'll write it down on our paper that we're doing it. Deal? Okay. Let's check our answer now. Because for these problems that I'm showing you how to do, every single one of them is checkable. You should never finish a problem and not know whether it's right or wrong. The check is 2 steps. We need to check 2 things. The first thing is I'm going to check to make sure that our solution, when I plug it back in for theta, gives me negative 0.32. Cameron, will you pull the door shut for me while you're right there? So I'm going to do sine, and then press second and the negative sign, and that gives me the ANS command, which is the previous output from my calculator. In this case, that 3.467, yada, yada, yada. And that gives me the desired result. That's step 1 of my check. Everybody's okay? Yes, sir.
Did you do the answer thing, Mr. Blue?
Second, and then the negative sign. So right down there by the enter.
Oh, okay.
The next thing I want to check is to make sure 3.47 is in between pi over 2 and 3 pi over 2. So the easiest way to do that is to just convert them both into decimals. So pi over 2, well, my answer is bigger than 1.57. So we're good on that end. And 3 pi over 2, well, my answer is smaller than 4.71. So I'm convinced I have the correct answer. That it gives me a solution to sine equals negative 0.32, and it lies in the desired interval. So I want to take a minute now and talk a little bit more about writing this equation and how we do that. Okay? So the number here is always going to be the part of the x-axis that makes up our alpha. Right? Our alpha is always drawn between the x-axis and the terminal side. The part of the x-axis that makes up our alpha is going to be the first part of my theta. And then whether I add or subtract alpha is going to depend on which axis I cross right before I get to the terminal side. if my solution, if my alpha, or I'm sorry, if my theta is going to be a positive number, and the axis I cross is the x-axis, right before I get to alpha, or before I get to the terminal side, I'm going to be adding. If it's a y-axis, I'm going to be subtracting, unless my answer is negative, in which case it just flipped rules. So x is subtract, y is add if it's negative. We'll do examples to cover all these things here in a moment, but I just want to talk about like how I'm setting up that equation for theta, how I'm using my picture to tell me what to write. Okay, that's the trickiest piece. But that's why I'm taking the time to draw the picture in the beginning, is so that I can write that equation for theta. So it's all going to just come out of the picture. Okay, so again, the first number that I write is going to be the x-axis, part of the x-axis that makes up alpha. Whether I'm adding or subtracting depends on which axis I cross right before I get to the terminal side. And then the alpha is always the same. All right, let's do another example. Bless you. Okay, so let's say we're doing cosine of 0.32 between pi and 2 pi. So I'm going to start by drawing my picture. My answer is positive, right? It's between one quick second here. Yeah, that's good. So I'm going to start going counterclockwise. So 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So I'm going to cross 0 out and put a 2 pi there now. Every time I pass something a second time, I'm going to cross out the old value, write in the new one. Everybody's okay with how I counted that out? So between pi and 2 pi is quadrants 3 and 4. So far, so good. I'm going to now narrow that down by observing that cosine theta is positive. So if I do my all silly turtles crawl, which two quadrants am I looking at for cosine being positive? Good, 1 and 4. Everybody's okay there? The letters tell me where the things are positive, right? A for all, and then C for cosine. So there, my answer is in quadrant 4. So there's my theta. Everybody happy with what I've done there? Let me draw in my alpha. Yes, Emily? Sure. So alpha is going to be cosine inverse, absolute value, 0.32. Oops. Now, again, I recognize that absolute value of 0.32, I don't really need to write the absolute value there, but I'm going to write it every time, right? when I type in my calculator, I won't bother with it, but I'm going to write it on my paper because if I get in the habit of not writing it or trying to only write it when I need it, I'm going to forget. So I'm going to write it every single time, even if I don't actually need it. Everybody's okay so far? Okay. Now we're going to write our equation for theta. So theta equals, the part of the x-axis that makes up my angle theta is 2 pi. Because the last axis I cross before the getting to the terminal side is a y, I'm going to subtract, and then it'll always be alpha. Is everybody okay with how I set up the equation? Oops. Come on. There we go. I don't know why that seems to do it, but it seems to fix it. And now I'm just doing the absolute values in my head. I'm not going to bother typing the absolute value stuff into my calculator. You can if you want to. I'm just going to do that part in my head. The absolute value of 0.32 is just 0.32. So there's my answer, about 504. How's this going so far? Is this all right? Trying to go really nice and slow and systematically. If you can get your picture, it's pretty easy after that, Max.
So, you go from the equation up top to the bottom. Where does the 0.32 go?
So, when I typed in my calculator, I did 2 pi minus cosine inverse 0.32.
Okay.
Right, because alpha is just cosine inverse of the absolute value 0.32. So I don't do them separately. I just wait and just do it all in one line because it's just less to write down, basically. All right, let's check this now. So the first level of my check is I'm going to make sure that cosine of 5.04 gives me 0.32. So cosine and gives me 0.32. Yes. And then I want to make sure that 504 is between pi and 2 pi. So 504 is bigger than 3.14 and smaller than 6.28. So satisfies the equation, is in the interval. I'm positive I have the correct answer. What do you guys think? It's okay. Let's do one more example, and then I'm going to set you guys loose. Sound good? All right, one more. And then let's go from all right. What makes this one a little bit trickier? Not the tangent. It's this piece telling me that my answer is negative, right? It's between negative 3 pi over 2 and negative pi over 2. That's the part that's going to make this a little bit trickier. Everything else is going to go exactly the same, but because my answer is negative, when I count, which way am I going to be counting? Clockwise. So between negative 3 pi over 2 and negative pi over 2 is quadrants 2 and 3. So far, so good. Tan is positive. Well, all silly turtles crawl. So we are positive in A and T. So my answer is there in quadrant 3. So far, so good. So I'll draw in my alpha. So alpha is going to be tan inverse, absolute value, 2.16. And now let's write our equation for theta. Theta equals the part of the x-axis that makes up my alpha. Then I look at what the last axis I crossed was, which is the y. Now, my answer is negative, so instead of meaning subtraction this time, it means addition, which is the part that trips everybody up, is that rule of when to add and subtract just switches if you have a positive answer versus a negative answer. But now it's just calculator time. Again, I'm doing the absolute value in my head, so I don't have to type in the calculator. So I have negative 1.94. And let's do our check real quick. So tangent of that should give me 2.6. It does. And that answer should be between negative 3 pi over 2. So it is bigger than negative 4.7. Remember, negatives, like negative 4 is smaller than negative 1, right? So everything is like kind of sneaky over there. It's like, oh, Mr. Kulik, I hate these negative ones. Yeah, I know. And this is smaller than negative 1.57, so we are good. Usually if you just look at the two things and be like, yeah, that's in between them, that's usually good enough. But what do you guys think on this? So it's okay?
Pretty weird to look at it first.
Once you've done the process and you realize that, oh, it is literally like every problem is now exactly the same. I can do all of them the same. I don't have to like try to think, oh, do I have to do something different here? It's just like, nope, it's just the same set of rules. You just apply the rules and just, if I can set it up correctly, it should be smooth sailing. That's the goal when I cook up, like, how do I want to show this to you? I'd rather have it be a little bit complicated, but always the same than like, oh, there's shortcuts to do this one or that one. It's like, no. I don't want you to have to like decipher when to do what. Let's just have it always the same. And maybe it's a little bit more complicated at times than maybe it needs to for a specific problem. But I'll trade the same all the way through for a bunch of different ways that you have to do things. You know what I mean? Everybody happy? Okay. So the remainder of class, I have 2 sheets for you guys to work on. If you haven't finished your Delta Math, you could work on that if you want to start on that before you do these. But they are 2 worksheets. Worksheet 2, or I'm sorry, worksheet 1 is using the unit circle. It's like the first example we did. Worksheet 2 is like these last 3 examples you'll be using your calculator. This will be part of next Sunday's homework set. So I think the only thing for Sunday is the delta math. The only thing for this Sunday will be the delta math. So this will be part of next Sunday's. If it's there, those drawings only have 2 votes. Don't move around. Like, you know what I mean? Always update. So it's kind of to your advantage that if you get it, let's get credit for it. Did you send me an email about that? Reach out. The only thing to do this Sunday is check that. Oh, stop this.